Already we have seen multiple linear regression. Multiple linear regression may be used to find the relationship between single continuous outcome variable and the set of predictor variables that might be continuous, dichotomous, or categorical. If categorical, the prediction must be recorded to the set of dichotomous dummy variable. Multiple linear regression which is two or more independent variables predictors. These are predictors are related to single dependent variables is much more common than say simple linear regression. Two general principles apply to regression modeling. First, each variable included in the model should be carry its own weight. It should explain unique variance in the outcome variable. Second, when you deal with the multiple predictors, you have to expect that some of them will be corrected with one another as well with the independent variable. Okay, where y is the dependent variable, beta naught is the intercept. No variable can be linear combination of other variables. So these are x1, x2 up to xn, x12. Okay, x-axis. Y-axis here distribution of this is the regression line y equal to beta naught p1x, this line. Okay, distribution of y1, this one, distribution of y2, distribution of yn. Okay, now we are getting this one x1, so this one here x1. Okay, here we got distribution of y1. Okay, so going straight beta naught, okay, beta 1 x1 x1. Okay, then again this is y equal to beta naught beta x1, beta 1 x1. Okay, regression line. Here correspondingly beta naught b1 x2, this one, this one. Okay, then we got xn, so that's why here. Okay, so beta naught comma beta 1 x1. Okay, this one only here shown. Next figure also you will see. Here the fitted line minimizes the sum of squared vertical deviations. The fitted line minimizes the sum of squared vertical lines. Okay, here the fitted minimizes sum of squared vertical lines deviations. So y equal to beta naught plus beta 1. Okay, this one total. Sorry, not straight. Okay, then this one here x-axis, y-axis. So here x down of x, x, x. This one beta not b1 x1. Here this one yi minus my of beta not beta 1 x1. Okay, here x1 y1 x value is like this. So then chapter logistic regression. We use logistic regression when the dependent variable is dichotomous rather than continuous. Logistic regression when dependent variable is dichotomous rather than continuous. Outcome variables conventionally coded as 0 to 1 with 0 representing the absence of a characteristics and 1 is presence. Okay, 0 is absent, 1 is presence. Outcome variable in linear regression is a logistic, which is transformation of the probability of a case having the characteristics in equation. Outcome variables in linear regression, output variables in linear regression is logistic, which is transformation of probability of a case having the characteristics in question. The logistic is also called the log odds if P is the probability of case having some characteristics. The logic is logit of P equal to log P divided by 1 minus P equal to log B minus log 1 minus P. The logit is also called the log odds. Log odds. If P is the probability of a case having some characteristics, logistic is log B divided 1 minus B equal to log B minus log 1 minus B, log of 1 minus B. That is P we have to deduct from 1, then how much we got, that one deduct from, subtract from this log B. Here log total P, then P deduct from here. If P is the probability of the case having some characteristic logistic, this is the probability. So how much we got probability, deduct from 1 total probability, how much we take. So all max deduct from 1 only. So here then we have to take log for that. Here total P, then this is cross multiplication. Okay. Cross multiplication. Okay, that's it. Log B minus. Okay. The logistic regression equation, the logistic regression equation with n predictor is the logistic regression equation. The n predictor is logistic P naught, P1 x1, P2 x2, Pn xn plus epsilon. Okay. Here already we have seen P naught value in the last regression. Okay. The differences to multiple linear regression using a categorical outcome are the differences to multiple linear regression using categorical outcome are. First, one side we will see that theta naught. Remember here. Y is the dependent variable. Theta naught is the intercept. So, theta naught is the intercept. No variable can be linear combination of other variables. So theta naught is the intercept here. Okay, na? Theta naught is the intercept. Okay. The difference to multiple linear regression using categorical outcomes are the assumption homogeneity common variance. This is the common variance. Is not meet with the categorical variables. Categorical variables. The assumption of homogeneity common variable variance is not meet with the categorical variables. Multiple linear regression can return values. Multiple linear regression can return values outside the permissible range 0 to 1. Okay. Assume independence of cases, linearity, there is linear relationship between. Assume independent case, linearity, there is linear relationship between logistic of the outcome. Logistic of the outcome variable and any continuous predictor. Logistic of the outcome variable and any continuous predictor. No multicollinearity, no complete separation. The value of one variable cannot be predicted by the value of one variable cannot be predicted by the values of another variable of set variables. As with linear regression, we have measures model fit for the entire equation, evaluating it against the null model with no predicted variables, and test for each coefficient, evaluating each against the null hypothesis that the coefficient is not significantly different from 0. That is, as with linear regression, we have measures of model fit for the entire equation. Entire equation, for example, entire equation, evaluating it against the null model, with no predictor variables, and test each coefficient, evaluating each against null hypothesis, that the coefficient is not significantly different from 0. The interpretation of coefficient is different. The interpretation of the coefficients is different. Instead of interpreting them in terms of linear changes in the outcome, instead of interpreting the interpretation of coefficient the intercept of coefficients coefficient is different. Instead interpreting them in terms of linear change outcome with interpret them in terms of odd ratios. Okay, ratio, proportion and rate. Three related metrics. The ratio expresses the magnitude of one quantity in relation to the magnitude of another without making further assumptions about the two numbers having them sharing the same units. Ratio expresses magnitude of quantity in relation to the magnitude of another without making further assumptions about two numbers having them sharing same units. A proportion is a particular type of ratio in which all cases in the numerator are included.